guys, that always makes me laugh. All right, so what we're looking at today, grade 7s, we're looking at congruent figures. And the first thing we're going to be examining is the definition of congruent. And in math, congruent is just a really simple or fancy way, whatever you want to look at it, that means equal or the same. So we're looking at these two shapes right here. These are both 1, 2, 3, 4 quadrilaterals. They've got a variety of measurements. And we want to look at the first question is which sides are congruent. So we're looking for same. So if I start off over here on the left hand side and I go line AD, and I see that it's 6 centimeters. So all I have to do is look over on the second one and find a 6 centimeter, and it's an EH. So we can say that AD, side AD, is the same as HE. They're both exactly the same. And we could just go through it exactly in the same process. We'd take a look up here. AB or BA is 3 centimeters, and that is the same as EF. And so we just write it, AB equals EF. We look at the bottom. DC is 8 centimeters long, and so is GH or HG. And the letters, it doesn't matter actually which way you put it. And finally, BC is equal to FG. Congruent also applies to angles, though. And these are really funky lines here, but this little single line right there and this little single line, those two angles are congruent. They're the exact same. So in the same way we did on the last slide, we just say, okay, well, angle C, which is right here, that's congruent with angle H. Now to differentiate angles, one line is equal to one line, and therefore two lines is also equal to two lines. So what is congruent to angle D? On the right hand side, angle G. And you just keep going. 3 lines or arcs, angle B, and that's equal to angle E. And finally, angle A, our big one over there with 4 arcs, is equal to angle F. Now, I'm sure you've asked yourself, you're at dinner table and you're like, hey, let's have a conversation about congruent triangles. And you're wondering, are there circumstances where two triangles are congruent? And there's actually 3 cases or rules that we have to follow. The first one is if you're given 3 sides of a triangle, believe it or not, there's only one triangle that can be drawn. It doesn't really matter how many times you try to redo it. It's always going to come up with this particular triangle. So you say, okay, I'm going to prove you wrong. I'm going to draw the side of 5 right here. Instead of putting 8 next to it, I'm going to put a 6 next to it. And you're like, 6. Well, this side, guess what, is going to be 8. 5 will be next to 8, and 5 will be next to 6. 5 is next to 8, 5 is next to 6. So if you're given the 3 sides of a triangle, every single time you have one possible triangle that you can make. You can't make any other ones. So we say, this is how we write it actually, down at the bottom here. You can pause the video. Triangle ABC is congruent to triangle FDG. A, B, and C, F to D to G, FDG. And so this is the first case where we have congruent triangles. The second one, sometimes there's little kids get a little confused with this. If I gave you a triangle that has one side is 5 centimeters, the second side is 6 centimeters, and it has an angle of 40 degrees, there's actually 2 possible answers. So here's the first possible answer. I told you that one side is 5 centimeters and the second side is 6 centimeters, and I said that one of the angles or given angle is 40 degrees. And so you say, okay, let's just put this 40-degree angle between the 5 and the 6. And you'd say, okay, let's make that exact same triangle just looking backwards this way. You could say that these 2 triangles are congruent. They're exactly the same. This line segment right there and that line segment, those sides will be exactly the same. However, if you do 5 centimeters on one side and 6 centimeters on the other side, but you do not place the given 40-degree angle between the 2 of them and you put it opposite, then that's actually a very different triangle. And you can take a look and you can see it right here. You've got this narrow little angle here of probably about 20 degrees or 25 degrees. On this side, this is what we first drew, where the angle, 40 degrees, is between the 2 dimensions that you're given. So in this case, triangle ABC is not congruent with triangle GFE. These are not congruent. So for rule number 2, the angle, it will be a congruent triangle only when the given angle is between the two given sides. Just try to remember that. The third one, sometimes we're given two angles. We're said, okay, I'm going to give you 60 degrees and 50 degrees and one side. It will be congruent if, and it's very similar to case number 2, if the side length given is between the two angles. So basically the two angles have to sit on the side length. That's an easy way to look at it. So this triangle BAC will be congruent with FDE because in both cases, if you take a look at it, you take your side length, draw your side length, and then just plunk the two angles down on top of it, and that will make two congruent triangles. So what are the three cases? Before I reveal, see if you can come up with the three cases where two triangles are congruent. Three of the same sides automatically is going to have two congruent triangles. If you see triangle BGE and it's got 5, 6, and 8, and there's one EFK and it's 5, 6, 8, they're congruent. It doesn't matter how you rearrange it. If two sides and the angle are between them, then that will make a congruent triangle. If the angle is not between the two given sides, it won't be congruent. And finally, two angles in the same and the side between them. So that's the one where I told you you draw the given side and plunk the two angles on top of it. And another way of saying this, if sides or angles are the same, we also say they're corresponding. That's it, guys.